Molarity. Molarity is first of all denoted as a capital M, and it is the number of moles of the solute in per liter of the solution. So molarity equals to the number of moles of the solute divided by volume of solution in liters. So its units are moles per liter, because the number of moles is the unit is mole and volume is in liters. And when we have the solution in milliliters, then we just multiply it with 1000, and even then you will have it as moles per liter, because we are basically converting ml or centimeter cube to liters. So number of moles of the solute can be calculated by using the formula mass of the solute divided by the molar mass. So molarity is the number of moles of a solute in 1 liter or per liter of the solution, and it is denoted as a capital M. There is one important thing I need to point out over here. It's slightly disadvantageous to use molarity. The reason being, when we heat a particular solution, then the volume of the solution will change. So this means that molarity will change with change in temperature, because volume is changing. That is the major disadvantage of using molarity. Now we've been given a numerical 2.46 grams of sodium hydroxide, whose molar mass is 40, is dissolved in water, and the solution is made up to 100 centimeter cube in a volumetric flask. So we need to calculate the molarity of the solution. So first let's write down whatever is given. Amount of NaOH is given, that is 2.46 grams. So this is nothing but the mass. We've been given the volume of the solution, which is equal to 100 centimeter cube, and we've also been given the molar mass of NaOH, that's equal to 40 grams per mole. So we need to first find out, for the molarity, we need to find out the number of moles. So the number of moles of NaOH will be equal to mass of NaOH divided by its molar mass. So here we've been given the molar mass as well as the amount. Amount is nothing but the mass. So 2.46 grams divided by 40 grams per mole, and this will give us the number of moles of NaOH, which is equal to 0.0615 moles. So grams is getting cancelled. Now molarity will be equal to moles, number of moles of NaOH divided by the volume of the solution, and this is since this is in 100 centimeter cube, we'll be using this formula, so ml or centimeter cube, and this is multiplied into 1000. Okay, so here we got 0.0615 divided by volume would be 100, and this is multiplied with 1000, and this gives us 0.615 molar. So molarity of the solution is 0.615. So first we were given the mass of NaOH, we were given the volume, and we were given the molar mass of sodium hydroxide. So first we calculated the number of moles, which is done by using the formula mass of that particular substance divided by its molar mass. This was then substituted in the equation for molarity. So molarity is equal to the number of moles of NaOH divided by the volume of the solution. Since this is an ml or centimeter cube, which are equal to each other. So since this is in centimeter cube, this has to be multiplied with 1000, because according to our definition is the number of moles in 1 liter of the solution. So there is one important thing called the molarity equation, which says M1V1 equals to M2V2. So in this particular thing, suppose there's a new solution being formed over the course of addition of a substance or anything. So according to that, M1V1 will be equal to M2V2, where M1 and V1 is the initial molarity and the initial volume, whereas M2V2 is the molarity of the new solution and the volume of the new solution. There'll be certain numericals which will require this particular equation. So molarity is denoted as capital M, and it is the number of moles of the solute in 1 liter of the solution. Molality. So molality and molarity sound quite similar, right? So molarity is the number of moles of the solute dissolved in 1 kilogram of the solvent. So in molarity we had spoken about volume, but here we are specifically talking about the mass. So number of moles of the solute in 1 kilogram of the solvent. So molality equals to number of moles divided by the mass of the solvent in kilograms. So because we are dividing this by this, the units of molality is moles per kilogram. So if it is in grams, we just multiply it with 1000, and number of moles of the solute would be equal to the mass of the solute divided by its molar mass. So the main difference between molality and molarity is the fact that there we had considered the volume of the solution, but here we are considering the mass of the solvent. Because of that, molality is more advantageous or more useful than molarity. Because molarity, when there is a change in temperature, there will be a change in volume. However, in case of molality, even if there is a change in temperature, the mass of the solvent will not change. Mass is the amount of matter present in the substance. So no matter what the temperature is, the amount of matter will stay the same. So that is why molality is advantageous over molarity, and it is denoted by a small m, and units are moles per kilogram. So here we've been given a question: calculate the molarity of a solution which contains 20.7 grams of K2CO3 dissolved in 500 ml of the solution. We've also been given the density. Now had we had to calculate the molarity of that solution, then we would have had we would land up just finding out the number of moles and then dividing it with this value. But now we need the mass of the solvent. So first, what's given? Mass of K2CO3 equals to 20.7 grams. Now molar mass of K2CO3 will be equal to mass of potassium into 2 plus carbon plus oxygen into 3, which is equal to 138 grams per mole. Now number of moles of K2CO3 will be equal to mass by molar mass. So mass, that is 20.7 grams by 138 grams per mole. So that's equal to gram will get cancelled, and this gets 0.15 moles. So the number of moles of K2CO3 is 0.15. Next, we need to calculate the mass of the solution. So mass of the solution, first of all, density equals to mass by volume. So mass will be equal to mass of the solution will be equal to volume into density. So the volume of the solution is given as 500 ml into density, which is 1 gram per ml. So this and this will get cancelled to give us 500 grams. So this is the mass of the solution. Now I can just substitute, right? No, because we need to specifically here, we need the mass of the solvent. We don't want the mass of the solution, we want the mass of the solvent. So the amount of water or the amount of the solvent, since it's not mentioned, I'm just going to write solvent because here we've not mentioned that the solution has water. So amount of the solvent will be equal to 500 grams minus the mass of K2CO3, which is 20.7 grams. This is equal to 479.3 grams. So here we had to calculate the amount of solvent. Okay, so molarity equals to the number of moles of K2CO3 divided by the mass of the solvent. And since the solvent is in grams, we need to multiply this with 1000. Right. So here we are just going to be substituting the values. So the number of moles 0.15 divided by 479.3 into 1000. When this is simplified, we get the value as 0.313 molal. Here it is molal. There in molarity we refer to it as molar. So we had been given a solution which has 20.7 grams of K2CO3 dissolved in 500 ml of a solution, and we'd been given the density. First we calculated the number of moles of K2CO3. Then we calculated the mass of the solution by using density equals to mass by volume, and from there we had to calculate the amount of solvent, because here we consider only the mass of the solvent. We are not considering the solution as a whole, we are only considering the mass of the solvent. Because of that, we had to calculate the amount of solvent, and basically we deducted 20.7 from 500. That gave us the amount of solvent or the mass of the solvent. So molality equals to the number of moles of K2CO3 divided by the amount of the solvent, which is the mass of the solvent in grams. Since it's in grams, we multiplied it with 1000, and this gave us 0.313 molal solution. So molality is the number of moles of the solute dissolved in 1 kilogram of the solvent. So molarity is better than molarity because even if there is a change in temperature, the value of molality won't change. Whereas in case of molarity, when there is a change in temperature, the volume of the solution changes, and because the volume of the solution changes, the value of molarity will also change. That is why molality is slightly more advantageous as a way of expressing concentration compared to molarity. So here one more important equation is number of moles of the solute equals to the mass of the solute divided by its molar mass.